Welcome to ReEngine's introduction of Simplified Drum Buffer Rope. My name is David Johnson, and I'm honored to be a co-founder and director of operations at ReEngine Consulting. Simplified Drum Buffer Rope, or SDBR, is a theory of constraints technique that ReEngine has successfully used within the public sector. In these projects, SDBR has helped to set the framework for transformative success in process improvement. Our discussion today will illustrate what ReEngine does during an SDBR implementation and the value it can provide to an organization. At a high level, drum buffer rope is a theory of constraints production methodology that determines the optimal release of work into the system so the constraint or primary bottleneck isn't overwhelmed. One way to look at it is, if a chain is only as strong as the weakest link, we need to strengthen that link, not overstress it. The same is true for processes and systems. By using drum buffer rope, the constraint is given the amount of work it can handle, when it can handle it. This keeps the system running smoothly and at maximum capacity. Simplified drum buffer rope is a relatively new evolution of this same idea. It has evolved to account for situations where there may or may not be a critical constraint in the process at any given time, and better handles the kind of fluctuating demand on services that is so common in government. The foundation of SDBR is Little's Law. Dr. John Little was an MIT professor that conducted some of the earliest work in operations research. During his work, he created what is now known as Little's Law. Little's Law says that your total cycle time equals the amount of work in process divided by the average rate of completion. While that may seem a bit complicated, in simple terms, it means that the amount of time the customer waits is equal to the amount of work the team has to do divided by the rate at which it does that work. So let's see Little's Law in action. There are currently 89 invoices in this accounts payable office that have not yet been processed. Your team can process 12 invoices every hour. A staff member within the agency or department brings in another invoice for processing from his group. How long will that staff member have to wait before their invoice is processed? 90 invoices represents the total work in process at this time, divided by 12 invoices per hour, equals 7.5 hours in customer wait time. Let's say that there is a factory that makes racquetballs. 100 balls are made for customers with a promise of 4 days for each ordered racquetball. This company targets and achieves 4 days as their average production, which you can see in the upper left normal curve. In this example, while the average performance of the company is 4 days, half of the customers receive their orders late. While 50% are produced by the average, about 85% are produced by +1 standard deviation, or in this example, 5 days. That is shown by the orange vertical line in the top right normal curve. So if we need to get our due date performance so that 85% of customers receive their orders within the 4-day promise, we have to shift our targeted average to -1 standard deviation, or approximately 3 days. If the achieved average is 3 days, the bottom right normal curve shows that such a shift would mean that 85% of orders are fulfilled within the 4-day promise. So how do we begin with SDBR? Despite the powerful analysis and insights that are achieved through SDBR, the data requirements are actually fairly simple. In terms of transaction level data, one simply needs a unique identifier for each row, the date the work, order, permit, application, case, etc. began, the date the work was completed, if applicable, any categories or types that might apply, and also the promised delivery date is needed for the analysis. This may be different by type or may be the same for all work. If there is currently no established commitment, ReEngine works with the team to establish statistical thresholds that can be applied. For the financial analysis, the number of staff that perform this work and the average or total salary for the group is also needed. One of the cool things about this analysis is that no matter the type of service provided, not a single byte of personally identifiable information is required. Once the data is gathered, it's run through ReEngine's SDBR algorithms, and the analysis is conducted. Once we have the data, a considerable number of powerful insights are then available to the team. In terms of performance, rather than having vague targets for improvement, a specific list of targets is available. In this example, this government team was able to see that to increase their due date performance to 85%, the team needed to target 19.5 days on average, with an ongoing backlog below 25 to be able to reliably deliver on-time services. This gives the improvement team a tangible target as their objective. Equally powerful are the financial insights related to improvement. In this same example, by achieving a due date performance of 85%, the cost to the organization for each quality unit produced would drop from nearly $500 to below $200, a decrease of over 61% for each permit in this case. Given how many the team does in a year, this represents value realized of over $314,000 each year. That's if the team isn't able to achieve more in a year, which they almost certainly will since they'll be able to produce quality work faster. Backlog itself also represents organizational value that is not currently realized. By reducing the backlog to 1/2 of the needed threshold, the team would achieve almost $280,000 in value realized. Eliminating that backlog completely would mean $285,000 in value realized. Having this sort of insight at the beginning of the project can help establish the mandate for transformative improvement and convince leadership of the need for change by clearly articulating the return on investment for the team's success. There are 3 primary advantages to adopting simplified drum buffer rope analysis. First, it quantifies the return on investment for each improvement initiative, making the case for change and assisting leadership in prioritizing projects. Second, it provides the improvement team with specific thresholds and objectives for the project. This will ensure focus at the constraint and maximize project results. Third, SDBR not only enables initial success, but ongoing success by setting continuous, scientifically established performance benchmarks. Whether an organization is just starting on their continuous improvement journey or they are already well established, SDBR can fit into its improvement strategy. A solid improvement infrastructure within a government or public sector organization has 3 key components. Improvement projects transform the agency step by step, generating enhanced value and working to transform organizational culture by proving the efficacy of continuous improvement. Leadership oversight authorizes projects, provides organizational support to practitioners, and holds teams accountable for results. SDBR provides guidance to both groups, illustrating the need for change to leadership and providing direction to the project team. Thank you so much for your generous time and attention as we introduce this recent evolution in the science of improvement. If you have any questions or would like to learn more, please feel free to contact us. If you'd like to work with ReEngine to utilize SDBR in your organization, please visit us at academy.reengineconsulting.com.